Hello friends, welcome back to your UPSC. So today we'll start with our third lecture on geomorphology, that is origin and evolution of Earth. So let's start with our third topic, that is origin and evolution of Earth. So there are various theories related to origin of Earth. Okay? So these theories are basically divided into two concepts. They are, first is religious concept and second is scientific concept. So religious concept, what exactly it is based on purely on religious beliefs of people that their gods or their deities have created this earth and the solar system. So it does not have any logical or any scientific basis. On the contrary to it, we have scientific concepts which are based on various experimental laws. Okay, so these scientific concepts are further subdivided into two types of concept. First is of thermal origin, and second is concept related to involvement of heavenly bodies. So the concept of this temperature, like hot and cold origin, have two parts, like concept of hot origin and concept of cold origin. So in concept of hot origin, what we see is this school says that initially, like, the temperature of the sorry the temperature of the matter from which our solar system or earth, therefore the earth, have been formed, has either always remained high or have increased during the process. Okay, so it was either high in from initial point only, or during the process it has heated up. And then we have second concept, that is concept of cold origin. The concept of cold origin says that our solar system, together with the earth, was formed of the matter which was either initially or have always remained cold. Okay, so what the hot origin says, that our solar system was either initially or was heated up during the process. And in cold origin, what it says, that it was from the beginning, or nay, it was either from the starting it was cold, or it has always remained cold. Okay, then second concept is the concept related to heavenly bodies, involvement of heavenly bodies. So what it says exactly is that how many heavenly bodies or stars have been involved in the formation of our solar system. So we have three parts in it, that is monistic concept, which says that only one, that is our primary sun, basically primary sun, is involved. Second is dualistic concept, which says that two heavenly bodies are involved. And the third one is binary star concept or trihybrid concept, which says that more than two stars were or heavenly bodies were involved. So today we will study only about the early scientific theories, and in the next lecture we will study about the modern theory, that is the latest theory, that is Big Bang theory. And I will also cover some religious concept, that is some religious theories based on Indian philosophies, which will help in geographical thoughts also. Now we'll start with gaseous hypothesis of Kant. So Immanuel Kant gave his gaseous hypothesis in 1755. Okay, so what this theory was all about, this theory said that our solar system is originated from the cloud of dust. Okay, so the Kant actually started with a few assumptions, which are like, first is, there were supernaturally created primordial hard matters which were scattered in the universe. Okay, like there's hard matter which is scattered throughout the universe. Okay, and second is, there is a slowly rotating cloud, okay, of gas, and it comprises of matter of very cold, solid and motionless particle. Okay, so there is a cloud which consists of cold, solid and motionless particle. And these particles are really very cold, like they are 0 degree Kelvin. Okay, and he also assumed that the particles begin to collide against each other under the mutual gravitational attraction out of a blue. So he did not explain why these particles started to collide with each other. So he assumed that they started to collide with each other. Okay, so now in this gaseous cloud, these are the particles, and they start to collide with each other. So as they are colliding, they are releasing some energy, because due to collision, the frictional force is generated, which releases heat energy. Okay. So due to this due to this collision, the heat is emitted, which is leading to increase in the temperature of this nebula. Okay. So the temperature of this nebula is rising. Okay. Temperature is rising, and due to their collision or their scattering, okay, their random motion, this the whole thing, that is the whole nebula, it start a random motion. And when this goes further, like the collision is more high and the temperature rises, this whole nebula starts to rotate. Okay, and due to more collision and more high temperature, it starts rotating very fast, at a very fast pace. So now this cold cloud, which was consisting of like very cold particles, has now become a hot rotating nebula. Okay, and due to rise in temperature, because the particles here are continuously colliding with each other, which are resulting into rise in temperature of this nebula, and due to rise in temperature, the rotatory motion is also enhancing, the rotation is also increasing, and this is leading to increase in size of the nebula. So now the nebula has increased in the size. Okay, and the rotation becomes so fast that the centrifugal force becomes very much higher than the centripetal force. Okay, so the centrifugal force become higher than the centripetal force, which leads to the bulging of irregular ring. So a irregular ring bulges out from the middle part, that is from the equator side of the nebula. Okay, and this ring is what actually is responsible for the formation of our planet. So these so when this ring is formed, it is thrown out due to centripetal force. Okay, so now one ring is thrown out, which makes our one planet. So likewise, 9 rings are formed and they are thrown out. Okay, so likewise, 9 planets are formed now. Okay, so we have 9 planets, and the residual part, that was the remaining part, it was now what is our sun. And what the irregular rings formed not, which resulted into the formation of planet. Okay, likewise all our 9 planets were formed. So this was the theory of Kant. But although this theory gained lot of popularity, but now it faced various criticism, because obviously due to various reasons. So we'll discuss the reasons one by one. The first one is, where did the primordial matter in the universe came from? Okay, he was never able to explain the source of the origin of primordial matter. Okay, he did not explain the concept of which caused the random motion between the particles. I hope you remember that there was a sudden random motion started in these particles. Okay, and the third one is, the collision of between the particles never generate rotatory motion. Okay, and the fourth thing is that can't assume that the rotation speed of the nebula increased the size, which was against the law of conservation of angular momentum. So these were the four drawbacks of gaseous hypothesis of Kant. Now next we'll start with nebular hypothesis of Laplace. So the nebular hypothesis of Laplace is considered as the modified version of gaseous hypothesis of Kant. So now let's start with this one. So Laplace was the French mathematician who gave his concept or nebula hypothesis in 1796, and Kant gave his hypothesis in 1755. Okay, so Laplace, what exactly he said, that Kant hypothesis suffered from three basic defects. First was that this much large amount of heat cannot be merely generated by the collision of the cold particles. Okay. Second is, mutual collision of the particles cannot generate motion in the primordial matter. And the third is, the angular velocity of the rotatory speed of the nebula cannot increase due to increase in size of the nebula. Excuse me. So, in order to remove all these defects, Laplace assumed certain axioms for his postulation. So, the first one was, he assumed that there was a huge and hot gaseous nebula in this space. So, the first problem of where the, like, from how the nebula was formed, that is where the clouds came from, this thing was solved. Okay, this problem was solved. And the second assumption was that from the very beginning the huge and hot nebula was rotating, okay, on its axis. So now the rotatory motion, that is the problem of rotation, was also solved. And the third thing was, the nebula was continuously cooling due to loss of heat. Okay, now the hot nebula was continuously cooling due to loss of heat, as the outer region was exposed to the external environment and it was cooling. Okay, so these were the three assumptions of Laplace. So now what his theory says, that there was a huge hot nebula, rotating nebula, which was cooling because of the external uh, exposure of its outer layer to the external environment. Okay, and because it was cooling, it was decreasing in size. Okay, it was contracting, and because of contraction, the velocity of the rotation was increasing, and the velocity of the rotation increased so much so that the centrifugal force was more than centripetal force. Okay, so when this stage was reached that the centripetal force is very less than centrifugal force, the material at the equator, it became weightless. So this material at the equator of the nebula, it became weightless, and consequently the outer layer was condensed due to the excessive cooling. Okay, this outer layer was condensed due to the excessive cooling, and so it could not rotate. So this part was bulging out. Okay, this whole ring was bulging out, and this part was cooling, because of which it could not rotate while still cooling and contracting the central nucleus of the nebula. So thus what happened was, the outer ring, this outer ring was separated. This outer ring was separated from the remaining part of the nebula. Okay, this is the ring, and it was separated from the remaining part of the nebula. This is the remaining part of the nebula. Okay. Now you see that there is one difference between the hypothesis of Laplace and Kant. In the Kant's hypothesis, there were 9 rings that were separated one by one, which were able to form the planets. Okay, the 9 planets. But in the Laplace theory, this single ring will form the 9 planets. Okay. So Laplace said that this ring was further divided into 9 rings. Okay. So these 9 rings were condensed at the point of naught. Okay. In the form of hot gaseous agglomeration. So these 9 rings were condensed in the form of hot gaseous agglomeration. Each such agglomeration was later cooled down. Like there is one agglomeration. It cooled down, and this cooling part formed the planet. Okay. Thus the 9 planets were formed from the 9 rings, and the remaining central nucleus of the nebula became the sun. So this was the ring, which was further divided into 9 rings. Okay. And this remaining part became the sun. Okay. The satellites were formed from the planets due to repetition of the aforesaid process of the mechanism. So the same mechanism, like this ring formed into hot gaseous agglomeration. Okay. And this hot gaseous agglomeration will have the high speed of rotation, because of which a ring will come out, and this ring will form the satellite. Okay. Form a satellite after it condenses. Okay. So this is how the planets and satellites of our solar system were formed according to the nebula hypothesis. Now let us evaluate the nebular hypothesis of the Laplace. So this hypothesis gained very much popularity for 150 years due to its simplicity, but later on this hypothesis was criticized due to few demerits. The first one was, Laplace assumed that initially there was a hot rotating nebula. Okay, but he did not describe the origin of that nebula. Okay, so we don't know where this nebula came from. Second, what was the reason behind the formation of certain fixed number of planets with an irregular ring? Okay, why did only 9 rings came out of the irregular ring? So this was the question, which was not explained by Laplace. Next is, the small degree of cohesion between the particles of the nebula would make the formation of ring a continuous process, not a intermittent process. That is, if one ring came out from this nebula, why not later on the another ring came out. So the Laplace was not able to explain this thing. So if the sun, the next point is, if the sun is the remaining nucleus of the nebula as claimed by Laplace, it should have some bulge around its middle part, but there is no such bulge. Okay? If we expect the thesis of Laplace that the planets were formed from the nebula and then the planets must have been in liquid state. Okay? So what Laplace said that the planets are formed from this nebula, and then these planets, these hot and molten planets, which were in liquid state, they started to rotate and revolve around the sun. But this is not practically possible as the liquid layers will not will have different speed as the let me explain you. This is the axis. If it is a liquid, then this layer will have different speed than this layer, and this layer will have different speed than this layer. So rotation and revolution of the planet, of any body which is in liquid state, is not possible. Okay. The next one is, according to the nebula hypothesis, all the satellites should revolve in the direction of their father planet. But the fact is not so, because the direction of the few satellites of Jupiter and Saturn is in is not exactly in the direction of revolution of their parent planet. Okay, so this was not explained by Laplace. Then next point is, some physicists, they postulated that the mass of the ring was not enough to provide the gravitational attraction for the condensation to form an individual planet. So, which, due to this postulation, the nebular hypothesis was not was considered a big failure. Okay, and the last one is that the nebular hypothesis was not able to explain the particular distribution of the present day angular momentum of our solar system. Okay, so because we have like 99.9% weight is with sun and only 0.1% of the total weight of the solar system is with all the planets. But if the angular velocity we will see, that angular momentum we will see, then it should be like opposite. Okay, that is like more than 99% of the weight of the total solar system should be concentrated in the revolving 9 planets, and the remaining 1% should be contained by our sun. Okay, so this was not explained by Laplace. So these are the demerits of Laplace. So now next we'll start with tidal hypothesis of James Jeans. Okay, so this is tidal hypothesis of James Jeans. Sir James Jeans is a British scientist which propounded his tidal hypothesis in 1919. Okay, so in this hypothesis, he gave some self-proven facts, which are, first is, the solar system was formed from the sun and another intruding star. Okay, so there were uh, two heavenly bodies, that is, it is dualistic theory. Okay, so there are two heavenly bodies involved in the formation of our solar system. Second, in the beginning the sun was big gaseous matter, gaseous mass of matter. Okay, so initially the sun was a big gaseous mass of matter. And the third is, beside the sun there was another star termed as intruding star. Okay, so there is a sun and there is an intruding star which will come close to sun. Okay, the intruding star was much bigger in size than the primitive sun, and this star is much more bigger in size than the our sun, primitive sun. Okay, the intruding star was moving along such a path that it was destined to come closer to the sun. Okay, so like here it is far away from sun. Now it will come closer, and here there will be very less distance between these two. Okay, then it will again go farther away from the sun. There was a great impact of tidal force on the intruding star on the surface of our primitive sun. Okay, because this was big in size. Okay, this star was big in size and it has come very close to sun. It had a great impact, that is great tidal impact on the primitive sun. Okay, and because of which our solar system is formed. So now let's start with the theory. What exactly the theory says is that a huge mass was ejected from the primitive sun, which later on became the building material of our future planets. Okay, a huge mass was ejected. Okay, like how it was ejected, now we'll see that how it was ejected. It was ejected by the gravitational force of intruding star. Okay, so how the huge mass was ejected, the path was like this. Okay, the path of the intruding star was like somewhat like this. It was far away and then it was destined to come closer to the sun. Okay, so now when it came closer to the sun, the force of attraction was so much so that some part of the sun burst out in the form of a nebula, we can say, and then the star went away. Okay, so the intruding star was continuously moving along the such path that it was coming closer to our primitive sun, and thus exerted a gaseous tidal force. Okay, a gaseous tidal force was exerted on our primitive sun, on the surface of our primitive sun. As the intruding star came nearer and nearer, okay, this bulging was like this. When it was this much away, a small part was ejected. When it was very close, more was ejected. Okay. When it got far away, like it was going, a little bit part was ejected. Okay. So when intruding star came the nearest, the gravitational force became maximum. I'm so sorry. When the so I'm sorry. Actually, I'll explain it again. So when like how this bulging was how this bulging process was going on when the star was here. Okay, when the star is here, a small part will come out. Okay, this part will come out. When the star became came nearest to the sun, the maximum amount was burst out. Okay, and when the star was going away, far away, a little bit like same this type part of sun came out. Okay, so like this shape was formed. Okay, so giant cigar shaped tide was formed and the thousand of kilometers in the length and was created at the outer surface of the primitive sun. This was thousands of kilometers in length. Okay. Ultimately, the huge mass of the matter in the shape of cigar was ejected from the primitive sun. Okay, and this was ejected from the primitive sun. We can see that it has more of the mass in the middle, and it has tapering ends. Okay, so this is what is the shape of our solar system basically. Jupiter and Saturn, okay, they are having the highest volume, so they are in the middle. At both the tapering ends, we have small planets which grow up to become bigger, and then we have Jupiter, Saturn, and then again we have smaller planets. Okay, so this is how the filament was formed, and then this filament began to cool down as it was detached from its main father, that is the sun. So because of cooling and contraction, it broke into several pieces. Okay, and condensed. Each piece was condensed and formed one separate planet. This process, this whole process, like uh, formation of this nebula, and then condensation of this nebula, and breaking down into pieces which formed the planet. This process formed our nine planet. Okay, and if the question arises how the satellites were formed, so like when these planets were cooling down and contracting, some matter was ejected out which formed satellites. Okay, and hence we can see that the bigger planets have larger number of satellites than the smaller planet, and the very small planets like Mercury, Venus, Pluto, they do not have any satellites. Okay, now we have various evidences in the favor of this hypothesis. That is, first is the shape and order of the planet. Like shape and order of the planet is same as cigar shaped. Okay, then the number and size of the satellites is also the same, and the ordering and arrangement of the satellite is also like how it is. We can like guess out out of this, like how the satellites were formed and how they are arranged. Rotation and revolution and inclination of the planet's axis was also very well explained by James Jeans. He said that according to James Jeans, the planet were formed from the filament which were revolving around the sun. Thus, the planet of our solar system should also revolve around the sun. Okay? In our present day, the solar system, all the planets are revolving around the sun in the same direction as in the same orbit of the plane. Similarly, almost all the satellites of the planet are also revolving around their respective planets in the same direction as their father planets are revolving around the sun. Okay, so this was how this tidal hypothesis was postulated by James Jeans. Now let's start with the collision hypothesis of Jeffrey. So what Jeffrey exactly says that there were not two, there were three stars. Okay, one is the primitive sun, then is the companion star, and the third one is the intruding star, which was moving towards the companion star. Thus, the intruding star collided against the companion star. Okay, so the intruding star, and the companion star. This is our primitive sun. They collided against each other. Okay. Due to the head-on collision, the companion star was completely smashed and shattered. The companion star was completely smashed and shattered, like okay. And the this shattered portion of the uh, companion star were scattered all over the sky while the remaining debris remained around the primitive sun. Okay, some debris remained around the sun and others were scattered around the whole sky. Okay, however, the impact of collision and explosion enabled the intruding star to clear itself off from gravitational attraction of primitive sun. So because of this collision, like see, if this particle, this thing is colliding with this is heavier than this one. So when this is like intruding star and this is like companion star, when this intruding star is like collides with companion star, this companion star totally shattered off, and this companion intruding star was able to escape from the gravitational pull of primitive sun. Okay, because it experienced reverse force. Okay, so now the intruding star is gone and the companion star has shattered off. So we have remaining debris and some matter around. So the debris left out, they started to revolve around the sun and rotate on their own axis, and thus forming our solar system. Okay, so now so now the theory of James Jeans and Jeffrey together, it gained lot of popularity, but later on various demerits were found in this theory. First is that when stars are so far away, okay, the stars, universe is so vast that the stars are always very far away from each other, and there is a remote possibility or like negligible possibility that a star will collide with the another one. Okay, next is James Jeans did not explain whereabout and density of the intruding star which caused the tidal eruption of the surface of primitive sun. Okay, so the density of the intruding star was not explained. Next is next is uh, our sun is very far away from the planets. Okay, so if we consider this theory, then the planet should be heavier. Okay, and if they are not so heavy, that they should be closer to the sun. Okay, but this is not happening, which is actually against the angular momentum, the law of angular momentum. The next is the planet in our solar system are largely formed of the elements having high atomic weight, but the constituent element of the sun are light atomic weight, like hydrogen and helium. Okay, so the tidal hypothesis failed to offer the convenient explanation of this whole situation, that how it happened that hydrogen and helium, which have such a light atomic weight, were converted into like iron, nickel, and all that, which are having very high atomic weight. Next is, so the last demerit is, the scientist says, if we consider that the formation of satellite is from this theory, like if we consider that the satellites were also formed in the same pattern, then the Mercury is very close to the sun. Okay, so the sun is applying very great gravitational force for that. So there should be a part which should bulge out from Mercury and then a ring, and then form a satellite for Mercury. But this is not happening. So why is this so? So James, Jeans, and Jeffrey were not able to explain these things, and hence the theory failed. So, binary star hypothesis by Russell. So, H. N. Russell is a American astronomer. He gave his theory in 1937. It is a very simple theory. You'll understand it. So, we have three stars. One is our primitive sun. Okay. The next is our companion star. The companion star is revolving around the sun. And the third one is our approaching star. So, what the case is, the companion star is rotating around the sun. Okay. So, what the case is that the companion star is rotating around the sun, and there is an approaching star. Okay. So, this approaching star, it comes near, it is moving in opposite direction. Firstly, it is moving in opposite direction as compared to approaching star, and hence it is very far away from the primitive sun. So hence there is no gravitational force, push or pull, on our primitive sun. So as the approaching star is coming near to the companion star, we find that there is a bulging in the companion star, and it is same cigar like we did in tidal hypothesis. Why the cigar was formed, when the star was came closer, the bulging started. Okay. And then when it was very close, the bulging was maximum, and then when it went away, the bulging decreased. Okay. So like this, the bulging was formed, and this bulging was detached from the companion star, that is the parent body, and they started converting into the planets. And then this ejection matter, okay, this ejected matter formed our 9 planets, and that is the whole theory. Okay, that is the whole theory. So what are the this is the whole theory, and now we will see what are the demerits of this theory. First demerit is that Russell was not able to explain where the companion star has gone after all this happened. Okay. And the second thing is, at the time of formation, we're far off from primitive sun. Okay. The planets were far off from primitive sun at the time of formation. Even they were also distantly placed from each other. But after the disappearance of the giant intruding star, the planets were brought under the gravitational domain of the primitive sun. Then how is this possible? Okay, so this is our primitive sun, this is the companion star, this is the bulging. Okay, so this bulging went in the direction of approaching star, but it cannot go further more because the star was going in this direction, and it was very fast, and so they remained here. Okay, so they were not in the domain of primitive sun, in the gravitational domain of primitive sun. So how later on they came in the gravitational domain of the primitive sun? Okay, next, the residual companion star, which was nearest to the primitive sun, could not come within the gravitational field of the sun. Okay, so this bulging, this emerging mass, ejected mass, has come in the domain of under the domain of primitive sun, and the whole companion star, the whole body, has went away nowhere. I don't know, we don't know and that where it has gone. Okay, So this was much closer to primitive sun than the ejected matter, okay, that we can see easily. And this one has gone, like, we don't know where it has gone. And this one has come in the domain of primitive sun. So Russell was not able to explain how come this companion star does not come in the domain of primitive sun. Okay. And the third and the last, Russell did not elaborate the process of mechanism through which the planets were formed and how the satellites were formed. He did not explain anything about how the planets were formed, how the satellites were formed, how they were brought into the gravitational field of the sun. Okay. The next one is supernova hypothesis of Whale. So F. Whale was a mathematician from UK. He gave his hypothesis in 1946. So what exactly the theory is? We have a sun and a companion star. Also, we can call it nova. So in nova, we all know that there is nuclear fusion and fission in the sun, okay, in the stars. So in nova, because it is bigger in size, okay, the intense heat was formed by the intense heat. Sorry, I'm so sorry. This is our sun. This is nova. So in every star we have like nuclear fusion process going on. That is hydrogen atoms combine to form helium. So in this process, when the hydrogen, two atoms of hydrogen, they combine to form helium, huge amount of heat is evolved. Okay. So this process was going on in our primitive sun as well as in the companion star. But in the companion star, the process was going on at much higher pace as compared to the primitive sun. Okay, so as the process was going at very high speed, all the hydrogen was exhausted. Okay, hydrogen nuclei of the companion star were consumed, and the nuclear reaction, okay, the nuclear reaction process was collapsed, and because of which this nova star, it exploded violently. Now this nova star has exploded violently, and it's exploded so violently that the enormous amount of dust, mass of dust, started to revolve around the primitive sun. Okay, and the nucleus of this nova star was thrown out very far away. Okay, due to explosion. Okay, so the gaseous matter which was coming out due to violent explosion of the companion nova stars changed into circular moving disk. So first it was like dust, then it arranged itself in a definite path, disk-like path. Okay, okay. Thus the matter of this disk became the building material for our future planets. Okay. Now, due to the intense heat and the nuclear fission, which became the reason for formation of heavy elements. Okay. Now we have like this dust was, it formed into disk. Okay, and there was very much heat. Okay, so this whole dust was very, very high in temperature. And due to high temperature and nuclear fusion process going on, various heavy metals like helium combine, beryllium, so they combine to form something other. So like this heavy metals like iron, etc., iron, helium, carbon, nitrogen, they all were formed. Okay, and now the degree of heat and pressure decided the level of heaviness of the element in the process. Okay, like the as much amount of heat you'll give and as much amount of pressure you will give, with that will only decide how heavy the element will be formed. Okay, the explosion of the supernova generated intense heat and pressure which formed heavy element. Okay, which formed our primitive Earth and other planets. Okay, so this theory says that our planets were not formed from a primitive sun but from any other source. Like in this case, we have like supernova explosion of the companion star which formed a planet. Okay, so now we'll see what are the demerits. First, we'll see what are the merits of this. So basically, three problems were solved by this postulation. First is the problem of great distance between the planet and the sun. Okay, so now we can easily explain why there is a great distance between planets and the sun. Second is the problem of angular momentum of the planets. Angular momentum now can easily be explained that how the planets were formed. Planets are of much less mass as compared to sun. And the third is the problem of heavier element of material of planets that were formed even when our sun is formed of lighter elements like hydrogen and helium. Okay, so in previous theory we have studied that the scientists were not able to explain why the planets are having such heavier elements even when the sun is having such light elements. Okay, now the last theory is no. First we'll see the demerits. Okay, so the before demerits, he explained that because of the explosion, the dust was thrown out, and this dust was thrown out was so far from the primitive sun that the planets are formed far away. Okay, the large so this shattered material of the violently exploded supernova was thrown up to great distance location, and thus the planets were formed far away from the primitive sun. And then second is the large amount of angular momentum of the planets even when they are having such a light weight than the sun. Okay, that 99.9% weight is in the sun, then also the 0.1% mass of the body is having such a high speed, such a high angular momentum was easily explained as the planets were provided this acceleration or this momentum by the supernova explosion. Okay, and the last thing is the material rendered denser and heavier due to intense heat and pressure that we have already studied, because this dust was so high in temperature and the pressure was so much that the elements combine more and more nuclear fusion, sorry, the nuclear fusion So the nuclear fusion was more and more, and which led to increase in the heaviness of the element. Okay, so the elements were more heavier as compared to the primitive sun, or the sun, elements in the sun. Now next and the last one in our earlier scientific theories is interstellar dust hypothesis. Okay, so the interstellar dust hypothesis was given by the Russian scientist, that is Otto Skemdet. He gave this hypothesis in 1943. Okay, so according to this interstellar dust hypothesis, what happens is our primitive sun, during its glaciatic revolution, it was able to capture this gas and dust cloud, okay, this dark matter from the space. Okay, so this is our dark matter which was captured by the sun, and this dark matter is having its own momentum, angular momentum, etc. So this dark matter actually have two things. First is dust and the second is gas. So the gases being light, they were initially the whole this whole dust was destabilized and was moving randomly. Okay, but later on the gas was being lighter, it was unstabilized, but the dust particles, they combined and arranged themselves in the proper pattern. Okay, that is the disc like pattern, they form a disc. Okay, because these dust particles were heavier, so they stabilized themselves, and because they stabilized themselves, they combined together and they formed a disk, and this disk was rotating in the direction, revolving in the direction of our rotating sun. Okay, so this revolution of the disk was caused due to three impacts. First is rotatory motion of the sun itself. Because of the sun rotation, this whole interstellar dust was collected. Okay, and because of the same rotation, this disk is moving around or rotating around the sun, revolving around the sun. Second is the gravitational force exerted by the sun on the disk of the dark matter. That is, our sun, it is attracting this disk, which is helping this disk to rotate or revolve around the sun. Otherwise, it would have been like this. That this is our sun. If it is not attracting, then this dust would have rotated, revolved like this, and then gone. Okay, but due to attraction of the sun, it is revolving around the sun. Okay, and the third is the angular momentum of the large dark matter of the disk. As I said that these had their own angular momentum also. So because they are having their own angular momentum also, they are able to revolve around the sun. Okay, so thus, under the combined impact of the three types of motion, each and every particle of the dark matter of the universe started redistributing itself on the basis of mass, density, and dimension. Okay, so this whole disk, it started arranging itself in the form of in the according to its mass, according to its density, according to its weight. Okay, as well as the existing amount of centrifugal force which was tending to push the particles away from the sun, and as well as the centripetal force which was tending to push the particles towards the sun. Thus the particles having large amount of centrifugal force were thrown out. Okay, and the particles which were having large amount of centripetal force were attracted inside. Okay, and the particles having larger amount of centrifugal force was thrown towards the margin, okay, of the rotating disk. So this was what happened to the dust particles, and the gaseous particles were thrown towards the margin of the disk by the intense heat of the sun, okay, which dispersed the gaseous particle, okay. The intense heat also formed heavy particles which remained in the inner band of the disk, okay. So in the inner band, heavier particles were formed, okay. The collision among the dust particles started the process of agglomeration and assertion around the bigger particles. Like these particles, they started to collide with each other, okay, and they started agglomerating with each other and started to form bigger particle, okay, which became the embryo of the future planet. But the gaseous particle could not condense as they could not be organized due to their continued motion. So, with the passage of time, these embryo captured more and more matter and thus grew in size to become asteroid. Okay, so this is dust particle. It collected more matter, and it became like this big, and then it formed asteroid. And it may be pointed out that the asteroid will were still inside the disk, okay, so they were also experiencing collision, okay, and they were revolving around the sun. So these asteroids further grew in size as they were agglomerating with other dust particles, and these dust particles, when combined with the hmm, when combined with these asteroids, formed planets, okay. So the planets were formed, and the other dust particles which were in the this disk, they formed the satellites, okay, satellites of the planet. And the lighter matters which were pushed towards the margin, and the heavier matters were pushed towards the inner band of the disk. So the planets formed in the inner band of the disk were having heavier matter as compared to the planets which were formed in the outer band of the disk, okay. So the planets of the disk which were on the outer band have low density as compared to the one which are in the inner band. So they were formed, so the outer band planets were formed by freezing out process of the gaseous matter, okay. So now this was the whole theory of interstellar dust hypothesis, and now we'll evaluate this theory. So this theory was able to solve our various peculiar problems like the near circular and similar plane of the orbit of the planets, okay. And second is why, firstly, why the orbit of the planets are nearly circular, okay. So this thing was explained by this hypothesis. Second is the revolution in the equatorial plane of the sun closely matching with the orbital plane of the planet, okay. The third thing is placement of the planet according to the size on the basis of well founded law. Now the planets are placed according to their size and their density, okay. The high density planet in the outer circle sorry, in the inner circle, while the low density planets were in the outer circle. And the large and peculiar distribution of the angular momentum among the planet of the solar system. So these were the things that were solved by this hypothesis. But there are some demerits, as the scientists said that the primitive sun was incapable of capturing the dark matter that was scattered in the universe, as the calculations shows that only the binary star system can capture the dark matter. Okay, and according to some astrophysicists, the meteors and the asteroids were formed as a result of disintegration of some planets, but in this hypothesis, it is said that the asteroid were formed first, and due to agglomeration of this asteroid with the other dust particles, our planets were formed. So this is the issue. And the second last is that till now no trace of dark matter could be discovered either in the astrological drilling on the Earth's surface or on any other planets. Okay, so the scientists are not able to find out any evidence of the dark matter, which the interstellar dust hypothesis said that the planets were made up of. Okay, so these are the demerits of this interstellar dust hypothesis. So that's all for today, guys. I hope you enjoyed the class. Though the topic was a bit lengthy, but it was interesting too. So we'll meet in the next lecture. Till then, take care.